Now, why do these graphs look like the way they do? Well, maybe if we get a table of values for each of these, you can kind of see the patterns of numbers here. So, and again, you can use your calculator at any time to do these. But let's just start off with the one on the left. Okay, if we plug each of these x values into the equation, let's see what our corresponding y values will be. So we have, if you plug in a 0 for x, 2 to the 0, anything to the 0 is a 1. 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, and 2 times itself 4 times is 16. So you can see, if you look at the base value, the b value in the equation, you can see that that's how much you're timesing each one by. Like you can notice that these are going up by 2's, like they're doubling each time. You double 1 gets to 2, 2 times 2 is 4, 4 times 2 is 8, and so on. Or you can move in a reverse order, and if you start it with the table of values, you could see that 8 divided by the previous one of 4 is 2, 4 divided by the previous y value is 2, and so on. So you can get the b value by dividing any y value by its previous y value. Now with the negative ones, okay, just keep in mind that if you have a negative exponent, and I believe this was done at some point during your grade 10 numbers class, but we did work with negative exponents in this course in the beginning part when we did algebra. So let's take a look at this. Okay, just a reminder that 2 to the negative 4 is not negative 16. A negative exponent doesn't make a negative number. It means we had to put this down on the denominator to make it positive, and that winds up being 1 over 16. So we can do that much, or you can do the decimal equivalent. It's going to be 0.06 or something like that, all right? And you can see these y values approaching 0, like 2 to the negative 1 is really 1 over 2 to the positive 1, which is 1/2 or 0.5. Then you get 1 over 4, 1 over 8, and so on. So what you can see is that as x gets into the negative numbers, the y values are approaching 0, which is the asymptote. So if you were to sketch all these points right here, once again, okay, you would wind up with something like this curve right here. So when I was putting in negative values for y, I was getting, for x, I was getting numbers for y that were closer and closer to 0. And when I was putting in larger positive numbers, then 2 to the 3, 2 to the 4, and so on, they were getting very big as we went on. So 2 to the 5 is 32, 2 to the 6 is 64. You can see that they're increasing at an increasing rate. And then if we go back and we take a look at these ones right here where you have 0.5 to the x, this is a decay function because the number that's to the power of x is between 0 and 1. Can never be negative, all right? If you tried putting in negative numbers into Desmos, you wouldn't get an exponential function at all. So we'll always have a positive number. But if you start using your calculator for these, okay, you're going to see the reverse happen. You're going to wind up getting these numbers right here and so on. Okay, you're going to wind up getting numbers that look like this right here. And just to show you, okay, if you had 0.5 to the negative 2, well, 0.5 is really a half. And then if we made each one of these negative, you don't have to do this, I'm just showing you why these things are true. Then we put them in reverse positions, switch up the numerator and denominator, and now the exponents are positive, and you get something that looks like this. Okay, so you don't have to do these calculations. Okay, you can use your calculator at any time, but you can see right here with these that we have the reverse happening. So what happens is when we sketch this graph, you wind up with something like this. And you can see right here as x gets larger and larger, this time the y value is approaching 0. So you can see here once again, okay, we have a horizontal asymptote of y is equal to 0, and for now that doesn't change. No matter if we do a growth or decay function, that doesn't change, neither does the y-intercept.